Good afternoon, everyone, and thank you all for joining the webinar. I'm Brian Bickle, Data Practice Lead at InterWorks. InterWorks is the leading data consultancy with a global reach from our offices across the U.S. and Europe. We cover the full course of the data journey, from network architecture and data management to visual analytics and custom development. We've helped countless organizations across every industry move further, faster, and smarter toward their goal of a sustainable data-driven culture. Today we have two treats in store. First, we'll be watching InterWorks' own Tableau Zen master, Robert Rouse, recreate his IronViz submission right before your eyes. And if that wasn't enough, Robert will be using Exasol to make the whole process faster, while at the same time working with a much larger data set. In case you aren't familiar with it, Exasol is a purpose-built, high-performance analytical database that enables users to work with very large volumes of data in Tableau. Robert will be talking us through every step in the process. After the presentation, feel free to ask questions where time allows, or reach out to either Robert or myself, and we'll be sure you're taken care of. With all that said, let's get started. Robert?
Thanks, Brian. So before we get into building the viz, I just wanted to make a couple of quick points about why I think it's useful to compare extracts and the performance when using those to Exasol. So I use extracts a lot and tell people a lot to use extracts because they're working off of a relational database that may or may not be optimized to do analytics on a live connection. And if they are optimized, it usually takes a lot of tuning to get there. So a simple way to improve performance in Tableau dashboards is to just pull an extract. So that's great for most situations, but after a while they can have some limits when it comes to scalability. And we'll talk about that a little bit later in this webinar. But generally, I think Tableau recognizes that extracts have some limitations, and I think that's why you saw at the conference last week that on their 3-year roadmap, they have a plan to replace that with a new database technology called Hyper. But what we have today, since we don't know when that's going to come about or exactly what it's going to look like, is a database technology called Exasol. So in my experience, Exasol is very comparable to extracts. It's as fast, in some cases maybe even faster. It's scalable, and it's low maintenance. So there's not the same kind of tuning that you would have to do with traditional relational databases in order to achieve that performance on a live database connection. But a question that I come across a lot is, well, you know, we can achieve really good performance with extracts through a couple of tricks like rolling up the data to a higher level of aggregation or slicing to a smaller time period. And those things work. They make your extracts small and much more manageable, easy file sizes. It doesn't take too long to build the extract on your Tableau server, things like that. But there's an illustration that I found at the conference that I think explains why I don't think that's the best solution, particularly for ad hoc analytics, when you're trying to ask questions and find the story in your data. My opinion is that when you're still at that level where you're trying to figure out what the data means, find the story that needs to be told, you need to have access to as much data as you can at the lowest granularity that you can and across a longer period of time than you might for operational reporting that just looks at one period of time, maybe a month or a quarter or a year. So you'll see that as we go along in building this viz. Let's just jump right into building things out so that you can see the difference between using Tableau extracts and Exasol. We're going to use this visualization that I built on stage for IronViz. This visualization did not win the competition. Curtis Harris did a great job, well-deserved win. I thought it was an excellent experience, great competition. I learned a lot from building this dashboard. So I'm going to go through this real quickly. These 3 main views of the New York City taxi snow days analysis. And these are the 3 views that we're going to rebuild Not entirely, not all of the finer details and formatting and things like that, but at least the meat and potatoes of what goes behind these visualizations and compare them between the two different database sources that we're discussing. One has just trip count over time for the year 2014, comparing that to snowfall records in Central Park. And we can do some comparisons to see that there's a cause and effect relationship between snowfall and taxi traffic. Also doing some calculations to quantify that in terms of dollar differences, what you might get on a normal day at a particular time of year versus what they actually got on certain holidays and snow days, just quantifying that impact in terms of fare, and also some mapping. And this compares what did drop-off patterns look like before a major snowfall, what did it look like on the day of 11 inches of snow, and what did it look like afterwards. So to give you some idea of the starting point for this, what we were all given in preparation for Iron Viz was this extract. And if you can see here, that's, let me make this a little bit bigger. That's around 14 gigabytes. At one point, it was actually 15 gigabytes. So that's a pretty big extract. It's a lot to work with. It rounds out to about 160 million rows. In fact, I'll just go ahead and pull that up, grab the number of records here. So that extract, 14 gigabytes, 161 million rows. Okay? Now, compare that to what we have in Exasol, which is more than just 2014. It's actually from 2009 through 2016. I'm going to pull a number of records on here. And that's just under 1.3 billion records. So it gave me that number of records pretty quick. Also to give you some idea of what we're working with, this extract is here locally on my laptop. And of course, the Exasol database is on a server in Oklahoma. I'm sitting here in Dallas, so there's not a world between us, but a little bit of wiring to go from here to there, which I don't have when I'm working with the extract. So one of the challenges that you have, though, when you're dealing with something that large is it takes a long time to download, first of all. Moving a file that size back and forth from a server to local or anything like that takes a long time. So that's one of the challenges that you have when extracts start to grow. But another challenge that you might have seen some people tweet about while we were building this during the competition was that nobody was saving their workbook as we went along. The reason for that is that if I were to save this right now, not even as a packaged workbook, but just save it as a regular Tableau workbook, it takes a few minutes for it to actually save the file because this extract is so big. It's not trying to compress the extract, but just the fact that it's connected to that is slowing things down. So those are some of the challenges. The way that I overcame that challenge in the Iron Viz competition was I shrunk it down in two different ways. One is I took a daily aggregate. So here we're just looking at daily totals, total of just 365 rows in that one. And for the map, I shrunk it down to just 3 individual days, which you can see here, the 19th, 21st, and 22nd, so that we can see really fine-grained detail from those 3 days. But again, it's only those 3 days. So I shrunk it down quite a bit in order to make it nice and snappy like this. What I'm going to build today, we're not going to shrink it because I really want to show you the process of finding this story in the first place. We had over a week and a half, almost 2 weeks, to work with the data, to find the analysis that looked interesting, come up with a story. And so that process was a process where I wasn't working with smaller extracts. So that's what we're going to see today, and we're just going to go right on into it. As I build this, just make note of how different clicks respond between the two different things. I'm just going to start with a really simple line chart. And we're going to look at number of records by day. Now, we're comparing this to snowfall, so, but first let me grab federal holidays and label those. Because when I first started working with this data set, I saw some dips in this trend line, and I looked at these over to the right, and I said, oh, December 25th, that's Christmas. November 27th, that's Thanksgiving, that's obvious. But these three right here are dips that it's not obvious what's going on. And I said, well, okay, it's winter. Maybe there was a blizzard. Maybe there was some big snowstorm. So we have Central Park weather data here, and I'll bring snow on so that we can see that comparison. And we'll change this to a bar chart. Go ahead and grab my drop lines. Some people got real excited about the drop lines. While we were up on stage, that was great. Thank you for the applause on that. Drop lines are great for this kind of analysis. All right, so there's that, and that's really most of what there is to it. I'm not going to spend the time doing a lot of the formatting things that I would do for a final presentation. But that's the nuts and bolts of what this view looks like. Counting trips, matching it up with weather information. Let's go ahead and do that same thing in Exasol. So number of records on rows. I'm going to put date up here. Pretty snappy so far. I'm going to go down to day. Now again, I said this is more than just 2014, so this is too much data. I am going to go ahead and grab a year filter so that we can navigate through years. This is not cached in my system at all. This is a fresh connection. I am grabbing this straight from a 1.3 billion row data set as we speak. And there's really no lag time. So big reason that I wanted to do this webinar is that I'm just really impressed with that personally. One of my first reactions when I got the data set originally was, man, I wish I could do this in Exasol because it would be a whole lot easier to manage and I can save as I go. So let's grab those holidays on here again. We'll work with 2014 for now, but there's something interesting that I found in preparing for this that I think you'll enjoy. Let's grab snow. We don't need that label. Make it a bar chart. And we're going to show this on highlight. Grab my drop lines. Okay. Yep. There's drop lines. Good. All right. So essentially the same thing. No real lag as we were building it. But now I can explore more than just 2014. And I want to because I want to see if there's anything else interesting about some of these dips. So I'm going to flip through some of these. Okay, 2013, this is kind of interesting. Maybe that's something that I want to look into because this doesn't go along with snowfall. This one here where there's some really big snow doesn't look all that anomalous, so that's kind of interesting. Let's also go to 2012 because there's one here that that stood out to me. Another one, here we got a fair amount of snowfall, I mean 4 inches. That's probably fairly normal for New York. But here, look at October. We've got October 29th here, really, really big dip, worse than Christmas. And I've got snowfall here, but that's not on the 29th. It doesn't account for that. So I happen to know in the back of my head that August through October, November can be hurricane season. So let's go ahead and just grab some wind information from this. And I'm going to have to unhide some fields here in just a moment. This is live analysis, folks. There is a field in here that, yeah, this WSF2. This is 2-minute wind gusts. So let me just rename that. You can probably figure out where I'm going with this by now. If I put wind gusts on here, and this -999 is just a bad data flag, so I'm going to filter that out. Make sure that wind is measured at least at 0. Okay. And we'll change the labels on this to just highlighted. Now, I can see that this one here on October 29th goes with max wind gusts of 38 miles per hour. And that's in Central Park. In fact, if you Google this, this does go along with Hurricane Sandy. So that's an insight here that we would not have gotten if we had stuck with just 2014. And I suspect that if we spent more time flipping through these years, we would find some more really interesting things like that. I'm personally interested in what this really sharp peak here is in 2010. Maybe that's something that we can Google later. But let's go ahead and move on. I'll save this sheet, call it the trend line. I want to move on to the spare gaps view. So that's going to be this one. This involves some calculations that are going to be pretty heavy lifting. And I want to talk through those as we go. So the first thing I'm going to do is just set up this view so that we can look at just the federal holidays and a few dates that we're interested in. So I'll grab the days, I'll grab the holidays. Actually, I want this to be an attribute, and I'll exclude. So now there's our federal holidays. I'm going to keep just those days. And I remember from our trend line that this one on January 21st was our biggest snow event. And January 20th here is Martin Luther King Day, so it's a federal holiday. I don't want to use that as my baseline. So remember that when we get to the maps. But I'm going to look for January 3rd, 21st, and 13th, in addition to these federal holidays. So there we go. All right. Now, these are the ones that we're going to be interested in looking at. What are those gaps in total fair amount, normal fair amount, and the comparison between those two. So I've got those calculations pre-written just for the sake of time in this webinar. I'm creating them here just to prove that this isn't something that pre-existed and is cached and all of that, so that you can see what it really is when you're doing live ad hoc analytics. So again, in my extract, I'm going to grab this. This will be my normal fair amount. I'll hit OK on that. Then I'm also going to create our fair gaps. And that's going to be this calculation here, just the difference between that normal calc, the actual day, and divide those two so that we get a percentage. Okay. So now, before I drag this onto the view, I want to talk through this calculation just a little bit more so that you understand the kinds of operations that each database has to do. So the first thing is I'm getting the daily total for every day of the year. So it's doing a date operation, truncating the timestamp down to the day level, and getting the total fair amount for every day of the year. Then what it's doing is it's averaging those daily totals across weekdays and across quarter. So what that means in English is that, for instance, New Year's, well, let's see, let's go with Christmas. Christmas Day was on a Thursday. So what's the total fares that you might collect on an average Thursday in the fourth quarter of the year? Okay? So it's doing 3 different date calculations, a nested level of detail calculation, and then aggregating that on top of that to sum up that result for that day. All right, so I'm going to grab the performance recorder so that we can get some hard numbers on what it looks like when we're pulling this in an extract. Again, this is not a real scientific benchmarking test. There's some pretty important differences in hardware and data location and things of that nature, but this should give you a practical feel for how things go. So I'm just going to drag normal fair amount over onto the view. This will take a few seconds because, again, we're working off of 160 million rows. And then I'm going to grab this fair gap and stick that on here. Okay, so not too bad off of the extract. I'm going to go to Help, Settings, and Performance and stop that so that we can get some idea of what that query time looked like. Okay, so one at 4.8 seconds, looks like one at 4.79. This bar chart does have a truncated axis, so that might be something going on in Tableau 10.1, I'm not sure, but 4.79 seconds and 4.8 for each of those queries that I just pulled onto the view. All right, now let's switch over to Exasol. And I am going to grab those same dates, but let's see, let's grab just the year 2014 so that we have a little bit more of a comparable comparison. I'm going to add that to context so that I know the level of detail calculations will work exactly the same. And we'll grab these two calculations, copy them over. All right, now we'll start building out our view the same way as before. We'll grab date, go down to the day level. I'm going to grab our holidays. Okay, and then we'll keep those holidays. And we'll bring in some additional dates, that January 3rd. And we're going to get the 21st and February 13th. So same dates as before. I'm going to show this year filter. Now, let's grab our fair amount. And I'm going to start the performance recording here in a sec at the same point that we started when we were working with the same thing on the extract. So let's go to Settings and Performance, Start Performance Recording. I'll grab that normal fair amount, stick that up here on columns. Again, this is some pretty heavy lifting by a database with 1.3 billion rows. It's over there in Oklahoma, but as you'll see, this is going to return in still a pretty reasonable amount of time. I'm also going to grab fair gap and put that up here. I would also point out that if this is something that you're doing routinely, then in both extracts and Exasol or really any other database, you can pre-compute these sort of normal day calculations so that you're not asking it to do that on the fly. But again, ad hoc analytics, I don't want to have to go back to my database and prepare a lot of things. So let's just see how that compared here. All right, so 13 seconds. Took longer than the extract. I can tell you that in other tests, the extract could take 10 seconds to 20 seconds. It kind of depends on what your computer has cached and different things like that. I had cleared out the cache beforehand, but at any rate, even though in this particular test, Exasol was slower than the extract, again, I would say that 13 seconds to compute nested LODs and 3 different date calculations on 1.3 billion rows on a remote server is still pretty doggone impressive. So I'm not disappointed in that result at all, and especially now that I can save this workbook. If I was to go over and save this extract workbook, it would hang up and I'd have to wait. So let's go ahead and move on to the maps. I'm going to save this for now. And what I mean by the maps, and I'll close off, no, I'll keep those. So on this map, we're looking at really, really granular data, and we're going to rebuild that and see what it looks like in both scenarios, extracts and Exasol. And then I'm going to show you some things that we can do in Exasol that we couldn't do in extracts, at least not today, with just the built-in capabilities of Tableau that are available as a built-in capability of Exasol. So again, we'll keep with this pattern of building it in both. I'll go over here, and one thing that I'm going to point out here on the map as we go along is that I have a calculation in here that will sample the data. Russell Spangler, one of the things that he did to avoid overplotting was use the random function and narrow down the number of points and just kind of sample it to something smaller. The way that I'm sampling it here is I take every minute of the hour and use this modulus 6 operation to break it into 10-minute increments. So that will allow us to take samples of the first 10 minutes of the hour and 10 minutes at the bottom of the hour, so minutes 30 to 40. So I'm going to go ahead and grab that just to scale down the amount of points that we're going to show on the map. And I'm also going to bring this down to just those 3 days that we're interested in looking at further. So that'll be, remember that January 20th was Martin Luther King Day, so federal holiday, not a great benchmark. So we'll grab 2 days before on the 19th, then we'll grab the day of the snowstorm, 11 inches, and the day right after. Then I'm going to build my map, just double click on latitude and longitude. Then I'll disaggregate the measures so that I get a point for every single drop-off. Zoom into New York. Okay. And so now the other strategy that Doc mentioned that you can use for dealing with overplotting on maps is you see how we just have sort of a sea of blue even after we've sampled to just the top and bottom of the hour. You can take the color here and just dial back the transparency so that those marks that overlap each other actually change the opacity. So the more opaque or the darker areas are the ones with more drop-offs. We'll split this out by day. So far, pretty fast. Just a couple of little times where I've seen queries taking maybe 3 or 4 seconds. So not too bad here. And we'll make this black so that it pops out a little bit better. All right, and there's our map. Now the challenge here, though, as you heard the judges say on stage on Wednesday, and I agree with them, is that the insight on this isn't readily obvious. You can kind of tell after staring at it for a while that these areas outside of Manhattan, you look at Brooklyn and Queens, the benchmark day a couple of days before, you can see some dark areas, darker dots outside of Manhattan. And if you compare that to the one just next to it, those areas are lighter, not as dense. You can kind of see that. And you can also see the next day how that changes. A better way, though, to do that comparison is to look at it maybe at a neighborhood level or the borough or some other kind of roll-up so that you just get a better sense of overall areas without having to try to figure out densities and things like that. So I'm going to show you that as we build this out in Exasol. So again, I'm going to grab that sample field and get 0 and 3 for the top and bottom of the hour. I'm going to grab just the dates that we want, so month, day, year. Part of the difference here being that when you pre-aggregate or pre-slice that extract to just the 3 days that you care about, those are the only 3 days that you can look at in detail. If you want to look at another 3 days, you're going to have to change the filters, recreate another extract, things like that. Here in Exasol, I'm not going to have to do that. So if we wanted to show this map and what that looked like for Hurricane Sandy in October of 2012, we can do that here in just a minute as well. So far, this is just as speedy as the extract, even though I'm downloading, let's see, 382,833 marks from the internet in real time as we talk. So I would say very, very comparable performance here in Exasol. So again, we're going to dial that transparency back down. I'm going to grab this to show 3 maps. Zoom in just a little bit. Now, one thing that we can do right away to help with just highlighting the part of the story that's interesting after you've looked at it for a while is we can grab this drop-off NTA name. So that's a taxi authority area. Corresponds roughly to neighborhoods. So if I grab that and put it on detail, what I can do now is that once this query is finished, just takes a couple of seconds here, I can put that as a highlighter and say, okay, well, now if I'm presenting this story, I can say, well, you know, click on this area just across the bridge. North side, south side is the name of this area. So if I click here, now all of a sudden I've got that area individually highlighted so that I can do a better analysis on just that one little section. Similarly, I could roll it up to that neighborhood. I can do lots of other kinds of charts. What I wanted to point out here, though, is that in Exasol, really what we did was we uploaded the geographical information to the database, and it has some built-in functions to do some spatial matching. So given the latitude and longitude that's available as the raw data, it can match up the areas inside the database as a built-in function so that we can assign that area name to the data. And that's something that right now you can't do in Tableau. It looks like it's on their roadmap with some of the spatial analytics they featured in the keynote. But just wanted to point that out. That's something you can do in database with Exasol without additional tools for spatial analytics. So there's our map. And we're running pretty good on time here, so I'll just go ahead and do a couple little formatting tweaks, put all of this stuff together. Actually, let's go back to this map for just a minute, and I want to talk through the scenario I mentioned here in 2012. So we have Hurricane Sandy, and that was on October 29th of 2012. So if we want to grab the day before, and maybe instead of just the single day after, we grab a couple of days after. So let's go from the 28th all the way through October 31st. This, to me, right here, is the value of having access to all the data as you think of questions, because now I can just change this date filter and find what I'm interested in. So we're going to go, what did I say, the 27th, 28th, 29th, 30th, and 31st. It will take a few seconds. It's got to bring a lot of data points down from our server in Oklahoma, which, if you're curious, is just one server. As you scale Exasol, you can have it on a multi-node cluster so that it has even faster performance for more users, more data in real time, things like that. We're running this off of just one node and some basic hardware right now. But here now, instead of 3 maps or just a small slice of time for a snowstorm, we've completely changed the story to what did this look like for Hurricane Sandy? And so we can click on that same area again, north side, south side, and see how that drop-off pattern changed for each of those days before and in the near aftermath of the hurricane. So some interesting things there. Let's go ahead and go back, and I'll put this together in a story. And as I'm putting this together, feel free to grab the chat window, send us questions, and I think we'll have some time here that we can maybe answer some of your questions. I'm not going to spend a whole lot of time with all the sort of visual effects that you would do for a finished, polished dashboard, but I'll just show a couple of things for the sake of completeness. For those of you that are interested, these are Unicode characters, upper half block and lower half block. They're not images. So you may or may not have noticed that. Just a neat little trick of something that you can do in story titles. So we're going to change this shading to yellow. And we'll grab our trend, bare gaps, and the map. We'll make this automatic so that it fills. All right, and I'm just going to do one more quick thing here and then turn this over. So if you have questions, if they've been piling up, I'll get to those in just one moment. Want to give everybody some time to think of what you want to ask and anything else that we want to go through and cover while we're here on the webinar. Okay, so there's our three views built in real time in both Exasol and extracts. Could spend a good bit more time formatting, tweaking, things like that, but hopefully this gives you a real good sense for the performance comparisons between the two. I think my takeaway from this is that nearly everything that we did, the performance was a one-to-one comparison. Really didn't notice serious lags in the time that it takes for Exasol to return queries, with the exception of some really, really heavy level of detail calculations that we saw in this bare gaps view. Which again, there are things that you can do in extracts to optimize that. There are things that you can do in databases to optimize that. I'm a very, very strong believer, though, in the ability to do ad hoc analytics. And am I willing to wait another 5 or 6 seconds on top of things in order to ask a different question? Absolutely, because the alternative is to wait several days or a week for a database administrator to build the view, to write some aggregate query or something of that nature for me. So having access to really, really granular data like this and being able to go back and forth, I think is the big value here of a database like Exasol. So I'm not seeing any questions come in right now. If you do think of other questions, here is our contact information so that you can follow up with us after the webinar. Feel free to contact Brian Bickle. You can see his email address there on the screen. He's one of our principal consultants. He's our data practice lead. Or you can contact me, analytics consultant at InterWorks, and there's my email address there on the screen.
Hey, Robert, it looks like we do have one question that came in from Michael.
Okay.
Hey, Michael, I'm going to read your question just so everyone knows what it is if they can't see the QA area. You asked, what factors have you seen play well in getting the most performance out of Exasol? So I'll talk about a couple things. I'm not going to try to get too far into the weeds here, but Exasol is a columnar database. It's an MPP scale-out system, so it can be scaled out over many nodes, and it is primarily in memory. So I can interpret your question a few different ways, but in terms of what kind of system you would hand it, it likes fast CPUs and lots of memory. In terms of data architecture or design patterns, if maybe that's what you were asking about, then really Exasol doesn't really have any opinion either way there. In the taxicab data set, we have one very, very granular trips table, which is literally one record for every taxi trip in the New York City area for, I think, 7 years. And then we have some dimension tables joined to that, as Robert's showing right now. So that would be kind of your more standard normalized structure, but you don't have to do that. We have other sample data sets that are just one giant denormalized table, and Exasol chews through those very well also. So hopefully I've interpreted your question 2 different ways I interpreted it, and at least one of those answers was useful to you. And feel free to drop me a follow-up if you've got more questions. Yeah, so second question there from Michael again. Users creating queries that tax Tableau's extract data engine, would it be fair to assume running in Exasol the performance improve? Yeah, generally speaking. So I'll, again, I mean, that one's a little ambiguous, but in terms of queries that tax the data extract engine, right, most of the time what the data extract engine is actually doing when it builds an extract is running basically select star either against a set of tables that were joined or against a table or against a view or maybe against custom SQL, and then returning that result set and then chewing through either building the extract on your local desktop or on the Tableau server, you know, the backgrounder processes and server, which can be very, very time intensive. Any Tableau server administrator that deals with large amounts of extracts running overnight and potentially failing or ballooning up the temp drive or the temp folder on the drive and then falling over kind of know that that can be a problem. So, yeah, I mean, that's one other thing that we really didn't talk about that Exasol helps with is preventing or reducing the number of extracts needed on Tableau server and that amount of time that the backgrounders spend building extracts. So I would say that, yeah, it's pretty safe to assume that if you have an environment with a lot of extracts and you move your old relational database to something like Exasol and get rid of all those extracts, you're either looking at a position where, you know, you save all that time in the middle of the night and you don't deal with building those extracts, or potentially you get yourself out of a situation where the extract creation process is falling over, and that's definitely a benefit and one in the win column for Exasol. So, yeah, Michael, hopefully that answers your question. Go ahead, Robert.
That in a couple of ways. One, just moving that extract around on a fairly high-powered laptop. I've got 64 gig of RAM and a solid-state drive. Moving that file around is a beast. And if you were to create that extract on the server, you know, most of the Tableau server administrators that I've come across would really not appreciate seeing a 14 gigabyte extract on their server because, like Brian said, it's likely to hog resources and potentially more than just overnight in trying to create that extract, because it would take a good bit of time to build that. And again, just the fact that Tableau server isn't meant to be your data warehouse. I think it's useful to have extracts that are smaller, more focused, particularly for things that are really routine, productionalized kinds of things. But for ad hoc analytics and trying to sort through and find the story in your data, I don't think that a monster extract trying to handle hundreds of millions of rows is the best answer there.
Sure. Yeah, Robert, that I think makes a lot of sense. Okay, moving on. I've got a question from Eric Thompson. Have you seen any variation in performance depending on server versus desktop? Eric, I'm gonna take that to be focused on Tableau server versus Tableau desktop connected to Exasol. No, I wouldn't say there's fundamentally a big difference in performance. I will share one interesting anecdote. When we were using Exasol and testing it originally, going through Tableau data server saved connections so that we didn't have to have all of our consultants download the Exasol ODBC drivers, we did actually notice that having to proxy the queries through data server was slower. And the funny thing is that's not an Exasol problem. That's just that Tableau data server in the Tableau server environment we had was actually too slow. So we were seeing increased overhead because Exasol might finish returning a query in like 15 milliseconds, and running it through the data server, might give you an extra 100 milliseconds of latency, which those are both very small numbers, but when you're already dealing with a database that will return queries in literally single milliseconds or double-digit milliseconds, adding any overhead is a substantial overhead. But no, if you're querying from Tableau server, like your workbooks are published to server and they're querying Exasol, that doesn't make any difference to Exasol versus just using desktop and connecting through the ODBC driver. Steve, I've heard Tableau employees themselves say that they are uncomfortable with extracts that are larger than 100,000 rows. Is it the same size at which you'd advise against extracts? I've heard a couple different numbers here, Steve, and InterWorks is certainly running into lots of different extracts. Okay, sorry, 100 million rows. Yeah, that sounds a bit more reasonable. I saw your correction there. Robert, I don't know what you think, but 100 million is probably a good number where I really think you're very far out of the realm of extracts. I don't know that I would say that's the rule of thumb. I don't know that I've got one that works all that well. But yeah, I mean, 100 million rows is probably pretty reasonable. And I think this depends who you're talking to within Tableau's organization. I've seen a lot of folks in the sales org who are very keen to say that extracts will solve a lot of problems, and then I've seen people in the development side of the org kind of backpedaling away from that and saying, they're great to speed certain systems up, but this is not a database. So Robert, I don't know if you've got any other experience there or any other guidance.
I do. I've worked with extracts that were hundreds of millions of rows of data, but weren't very wide, maybe had 5 or 6 fields, and were 2 or 3 gigabytes in size. So those worked okay. They did take a long time to build on the server. We actually had to extend some server timeout limits beyond 2 hours so that it could build the full extract. This extract that we've been working with here with the taxi data from 2014, that's 160 million rows. It does work, but again, when I hit save, in fact, I'm just going to go ahead and hit save. I don't know if you can see the spinner on my screen, but it's currently spinning, and I'll let you know when it's done spinning. I'm not packaging that extract right now. I'm not compressing that extract. I'm just using it. Those kinds of things can interrupt your process when you're trying to just work with the data. And when you see a spinner going for several minutes, you start to wonder, okay, is my computer about to crash? So there are things like that. Once you do have the extract, I mean, it does query pretty well. I think the biggest challenge is just in creating that extract in the first place and managing a file that large. But the variables involved there are both row count and the width of the extract. How many fields are in there for it to deal with? And so those variables in play, yes, I personally start to get a little bit nervous when I start seeing extracts measured in gigabytes, not megabytes, or over 100 million rows. Not to say that it can't work, but I start to really have concerns about how that's going to scale as time goes on, and you start to just add more and more rows.
Yeah, I think, Robert, one thing I can add on to that maybe might provide a little bit more nuance is that it's also has to do with the cardinality of the columns that are present. So one of the encoding techniques that Tableau uses to encode data in the TDEs is run length encoding. So, you can actually test this yourself if you do something interesting like taking the Superstore data and creating an extract, either using a database or some other technology that just duplicates that data, say 10,000 times. And we did this to produce an extract that was 83 million rows, but in the extract engine, we'll still compress it down to just like 10 or 15 megs, I think, or something very small, because that redundant data gets compressed very well. So you can do some fun party tricks like showing, hey, I'm using an extract that's 83 million rows, but they're, very, very high duplication, very low cardinality. So that will also produce a very small extract that's quite usable.
Yeah, and just to give you a little bit more flavor on that too, with this particular example with the the data we used in IronViz. Originally, when we were looking at it, it was about 3 gigabytes. That's because later on, as we started working with the data, some of the other contestants thought it would be valuable to have a unique ID as sort of a primary key for each row in that data set. As soon as Rouse Perez, the host of IronViz, created that unique ID, it blew up from 3 gigabytes to 15 gigabytes. And it's now 14 because we've excluded some messy data and some long points that are just way out in the ocean in South America and weird places like that. But Brian's right. Adding that cardinality from this unique ID field here really blew up the size of the extract. And it is done saving now. It took a minute or two, but it did save.
Okay, everyone. It looks like we've got about 7 more minutes in our scheduled time here. But are there any more questions? And so on the screen you should be seeing my email address and Robert's email address, so you do know how to get a hold of us. If you have any questions, or if you guys would like to discuss Exasol in any more detail, or how to deal with the solutions to problems of scale that you've got in your organization, we'd be happy to jump on the phone or chat by email or something like that and talk to you about this. And something else that we've done for some of our clients is we have done some POCs on data sets that our clients are working with on our Exasol cluster, just to prove out performance cases. So if that's something that would be appealing, then that would be something that we can also discuss.
All right, so hit us up with any questions. Thanks everybody for coming. Thanks to everybody that was there on Wednesday watching IronViz. Really appreciate everyone's comments. I thought it was a great experience again. Really proud of the work that everyone did up on stage. I think Curtis Harris made a great dashboard, well-deserving win. So great experience, and hope to be back in touch with some of the folks on this webinar, either at Tableau conferences in the future or to talk some more about Exasol.